So today we are going to learn about another logical operation, and this is called implication, and also this is called conditional statement. So let P and Q be two propositions. So the implication, or we can write this something like this: P implies Q. This is the implication, and this is a proposition that is false when P is true and Q is false. So this is false when P is true and Q is false, and true otherwise. Now this P is called hypothesis, and this Q is called conclusion. Now we can express this implication or conditional statement using various kinds of terminology, such as if P then Q, if P Q, P is sufficient for Q, Q if P, P implies Q, P only if Q, here Q whenever P, Q is necessary for P, Q follows from P, a necessary condition for P is Q, a sufficient condition for Q is P. So if we get any one of these sentences in our next examples or in this course, we can think that this is an implication. Okay. So let's move forward to the truth table of implication. So this is our hypothesis P, and this is our conclusion Q. So P implies Q. Now if P is true and Q is also true, the implication is true. If P is true but F is false, then as we have said earlier, this will be false. If P is false and Q is true, then this is true. If P is false and Q is also false, then this is true. So this is only the case when P implies Q is false. If P is true but Q is not true, then the implication is also false. Okay. Now let's move to an example, and I think the example will help us to understand the implication more clearly. Now let's say if I am elected, then I will lower taxes. So this is something like this form: if P then Q. So I am elected is P, I will lower taxes is Q. Now let's say I am elected and I have lowered taxes, and this is the expectation of the voters. Then if I am elected, then I will lower the taxes. So the expectation that I will lower the taxes, lowering of taxes will occur. This is true, and voters can simply expect this. Okay. Now, if I am elected and I do not lower the taxes, then this is not good, and the voters will not expect this from me. Okay. And if I am not elected, but a lowering of tax can also occur. Someone who has been elected, he can also lower the tax. So this can be also true. And if I am not elected, then voters do not expect that the taxes will be lowered. So this is also true. So the case when only an implication is false is something like this, that when P is true and Q is false. This is the case when P implies Q is false. Otherwise, this is true. So let's move to the other example here. If you get 100% in final, then you will get an A. Now, so you get 100% in final, this is P. Then you will get an A, this is Q. So P implies Q, this is P implies Q. So P implies Q will be false if you get 100% in final, but then you do not get an A, and you really expect to get an A if you get 100% in final. So now let's see that if you get 100% in final, you expect an A. So this is true, that the expectation is okay, this is correct. Now if you do not get a 100% in final, but you get an A, this is also possible because there are other factors such as midterm and class tests and assignments. So if you do not get a full 9 marks in final, you can also get an A in the course. Okay, so this can be true also. Now if you do not get an 100% in final and you do not get an A, this is also expected, that you didn't get any 100% in final and you also didn't get an A. So this is also expected, but this is cannot be expected, as the teacher says that if you get 100% in final, you will get an A. So you will feel cheated that you got 100% in final, but even that then you are not getting A. So in this case you will feel cheated. Okay, so this case this is false and all the others are true. I hope you understand this. So you have to remember this, that if P is true and Q is false, then P implies Q is false. Okay, so I think you understand. Now you can do this something like this also. You have done programming language courses. So if P Q now if something else, then there can be also Q. So you can something like this, that you can print here Q, just print here Q, and you can also print here Q. So if P, then it is must that P will be printed here. Okay, so if P is true, then Q will be printed here. Okay, now if P is true and Q is not printed, that is not possible. If P is true, then you will all obviously enter into this space and in this block, and you will, sorry for this, and you will have to print Q. So this is a false matter, that P is true but Q is not printed. Okay, but let's say P is not true but Q is printed. This can also occur in this next statement. See that if something else, then we are also printing Q. So this can also occur, that P is not true but Q has been printed, but Q is true. So this can also occur. And if we do not have this code snippet, then if P is not true and Q is not printed, then it is also okay that we do not enter into this block, and so P is not printed. So this is also reasonable. So that's why only this case is false, that if P is true, then we will all, and it is must that Q have to be true, otherwise this is false. So only this row will be false. I hope you understand what is an implication. Now let's move to 3 other definitions. So if the implication is P and the P implies Q, if this is an implication, then the converse of this implication is Q implies P. If P implies Q is an implication, then the contrapositive of P implies Q is the proposition not Q implies not P. Okay. And if P implies Q is the proposition, then the proposition not P implies not Q is the inverse of P implies Q, and this is the contrapositive of P implies Q, and this is the converse of P implies Q. So we have to keep in mind 3 of these propositions. Okay. So let's try to find out the converse, contrapositive and inverse of some propositions. Now let's say our proposition is the home team wins whenever it is raining. So this looks like something like this. We have seen earlier Q whenever P, and this is the same as if P then Q. So we can write this like if the home team So we can write this like, if it is raining, then the home team wins. So this is the same statement as the questions one. Okay. So we want to write the contrapositive of this implication. So the contrapositive was not Q implies not P. So we can write something like this. If the home team does not win, then it is not raining. So this is the contrapositive. This is the contrapositive of P implies Q. Okay. So this is the contrapositive. Now we want to write the converse. So the converse is like this. Q implies P. So we can write, if the home team wins, then it is raining. Okay. Now we will try to write the inverse of this. So the inverse is, not P implies not Q. So this can be written as, if it is not raining, then the home team doesn't win. So when we first get an example, we will try to find out what is P and what is Q. So as here we find whenever, so this will be Q and this will be P, and we will try to write this as in the simple form, if P then Q. So in the simple form we can write, if it is raining, this is P comes here, then Q goes here. So if it is raining, then the home team wins. Now if we try to find out the contrapositive, we will try to find out not Q implies not P. So this is Q, so we will have to write, if the home team does not win, to make it not Q, then it will not rain. So it is raining, it is not raining, and as it is raining is P, so not P is, it is not raining. So simply Q implies P will be, if the home team wins, then it is raining, and not P implies not Q is the inverse. So we can write it that something like this, that if it is not raining, not P, if it is not raining, then the home team does not win, and this is not Q. The home team wins is Q, so the home team does not win is not Q. I hope that we understand converse, contrapositive and inverse. So please write down these three propositions, and by the side of their name, that converse is Q implies P, contrapositive is not Q implies not P, and inverse is not P implies not Q. So you will have to remember this, as there might be examples further in the lecture, or you can have problems in the quiz also. Now let's move to biconditional. Let P and Q be two propositions. The biconditional is written like this: P, and this is the biconditional. This proposition is true when Q and P both have the same truth values. So, if P and Q both are true, then the biconditional of P and Q is also true. If P and Q both are false, so then the same, and otherwise the biconditional is false. So there are some common ways to express biconditionals. P if and only if Q. P is necessary and sufficient for Q. If P, then Q, and conversely. P if Q. This is IFF, and this is correct. We have to write like this. Okay. So this is the case when P implies Q is true and Q implies P is also true. Then this is the biconditional. So if we see the truth table, we can just find out why this is happening. Okay. So P, Q, and biconditional of P and Q. So if P is true and Q is true, the biconditional is true as we have defined earlier. P is true and Q is false, this is false. If P is false and Q is true, this is also false. And if P is false and Q is false, this is true. So this is the truth table of the biconditional of P and Q. So I will show you later why both P implies Q and Q implies P have to be true for this biconditional. See that if we have to write, if we find something like this: P if and only if Q, P is necessary and sufficient for Q, if P then Q, and conversely, or P if Q, then these are all biconditional statements. So these have to be clear that both of P implies Q and Q implies P have to be true to make the biconditional true. So let's move to an example and I will show you the proof later. Now the example is, if P is you can take the flight and Q is you buy a ticket, then you will have to find the biconditional of P and Q. So you have to find out P biconditional Q. So this can be written as you can take the flight if and only if you buy a ticket. This means if you buy a ticket, you can take the flight, and also if you can take the flight, if you can take the flight, then you buy a ticket. So both sides this have to be true. Okay, you can also write this like this. You can take the flight, and you can simply replace this with if. Okay, so I will show the truth table, that why we will need P implies Q and Q implies P both to be true to make P and P by the biconditional of P and Q to be true in our next lecture. But let's move to another topic now. So this is the precedence of logical operators. Now we have seen many types of logical operators. So the highest precedence is of the negation operator. So this ranks 1. Now the second is AND operator, then OR, then implication, and then bicondition. So if you get an exercise something like this, that P or not Q implies P. So now you have to do not first. So not Q will be done first, then comes AND operator. So you can write this as P or not Q implies P and Q. Now then comes the OR operator. So you can simply write it like this. So at last you have to do this implication. So if there are no brackets in the expression, you have to put some brackets to get the idea of doing which task you have to do first, and then which to the next, and so on. So let us draw the truth table of this expression now. This is a compound statement. So let's draw the truth table of this compound statement. So we have mainly two variables, P and Q. Then we need P and Q, and we also need not Q. Then P implies not Q, P or not Q, and then we need the total P or not Q implies. So let's create this table. So what are the possible combinations of P and Q? P is true, Q is true, P is true, Q is false, P is false, Q is true, P is false, Q is false. Now let's negate this. So this will be false. Not F is true, not true is false, not false is true. So let's do this column then. P and Q, so this will be true and all others will be false, as we have learned earlier. Now P or not Q. So P is true, and not Q is false, so OR will be true. P is true and not Q is true, then this will be also true. P is false and not Q is false, then this will be false. P is false and not Q is true, so this will be true. Now we know that, let's say this is X and this is Y, so X implies Y. In this case, on the false case is only that when this is true and this is false. So let's try to find out that this is true, this is X, this is Y. So X, this is true and this is false, so this case will be false, and also this is true and this is false, so it is false, otherwise those are true. So this is the truth table of the expression given in the example. So I hope that we can find out the truth tables of any kind of expressions by simply using precedence and then using these columns to create the final output that we want.